Started then. Cool. So this is the NumPy workshop. So yeah, we'll basically be spending time talking about the ins and outs of ND arrays, which are this data structure object that NumPy basically provides. So what is NumPy? Well, so Python has these data structures called lists. So they're just represented by square brackets, and a bunch of data can be placed into them and sort of grouped together under a single variable. So these lists are really nice and very flexible, but one issue with them is that they can be really slow when looking at like very big sets of data. NumPy basically creates a new type of data structure similar to a list in some ways, called an ND array, which is up to 50 times faster than lists. So it's much more useful for sort of different data science, data processing tasks, such as like machine learning or other types of data analysis. So this array object is much better, yeah, for handling large sets of data. And it's pretty similar to like matrices in MATLAB if you've ever used them. It sort of allows for a lot of different matrix operations to be performed on it. So just to sort of like a brief overview of how you actually get a hold of NumPy. So if you have Python and pip is basically, it stands for Python installs packages. It's basically a utility tool for Python to install different Python packages. If you have both of those, installation is really easy. It's basically just typing in your terminal or command prompt pip3 install NumPy. If you don't have Python or pip, it would probably be good to get them for just work outside of the workshop. But if you want to follow along with the code or anything for the workshop and you don't have access to those, then you can just use this website called Replit instead. And basically, you can just code short Python scripts online. You might have to like log in with a Google account or create a separate account to use it, but it's pretty handy for just sort of starting programming without much overhead of like downloading whatever or installing different things. And that sort of stuff can be a bit tricky, especially on something like Windows. So just sort of to start us off here, it'd be great for like me to get a sense of where you guys are all at with different programming things. So it'd be great if just like in chat or somewhere else, you could type out what you sort of perceive your level of experience to be in these 4 different areas. So general Python, sort of objects and classes, so object-oriented programming, and then lists and matrices. Yeah, I'm gonna try and see if I can actually view chat. But yeah, just like a quick 1 to 5 in each of those would give me a sense of how I should talk about this. Yeah, and don't worry too much about it. You don't need to get a super specific number, just sort of generally how comfortable you would be. Okay. Okay. All right. Okay. Well, let's see. Okay, cool. So yeah, so sort of, like I said, if you want to sort of follow along with the code and sort of play with the code as we go, you can open the Python interpreter in Replit or just locally if you have it installed. I'm going to post a couple links in chat. The first one is to this presentation if you sort of want to follow along with the slides. And the second one is just to sort of the code I'll be going over in these slides if you just want to pull it up separately. Yeah, so 2 separate links are there. But yeah, so sort of just jumping in. So with Python, when you want to use outside code, so something like NumPy, usually outside code is grouped into things called packages. And when you want to use those packages in your code, the first thing you need to do is just download the package onto your computer. But then separately from that, in the actual Python file, so the .py file that you're writing to run your code in, you're going to need to use an import statement. So import basically means take this package and like, I want to use what's inside of this package. So once you've downloaded NumPy, you can basically use it in Python by typing import NumPy. A lot of the time you're going to see this as import NumPy as NP. And basically what that means is that instead of referencing things from the package as NumPy, you're going to reference them as NP, which is just a bit nicer because it's shorter to type. And that's, you know, if you're typing out NumPy a lot, you'll understand why people prefer to type out NP instead. Yeah, so that's basically what this means. It's importing the NumPy package as, and it's just referencing that package as NP. And NP could be theoretically anything. You could import NumPy as, you know, text, and then you would just use text to reference it. But like, yeah, this is the same as sort of like any variable, you know, it can be anything, but commonly it's just NP. So yeah, that's sort of the first step, is just importing it into the Py file where you'll be doing your coding. So if you haven't seen a Python list before, this is sort of what the syntax looks like right here. So you'll see my list equals, and then in the square brackets, the elements of the list. So it goes 1, 2, 3, 4, 5, just a list of numbers. And the cool thing about lists is that all of these values can now be referenced through this single variable. So one way to create an ND array, which is basically the array object that's a lot faster than a list and that you will commonly see in data science, is to initialize the array from a list. So we've initialized this myList variable with these values. And then we can use the NumPy function array. So NP right here is referring to the NumPy package that we just imported. So you'll remember we imported it as NP. So np.array, so this is the name of the function from the np package that we're referencing, np.array, and then pass it myList as the parameter. So basically what this is going to do, what this function, this array function is going to do, is it's going to take the myList object and convert it into an ND array. So my array is going to be an ND array, and it's going to have these values inside of it. And if we print my array, we'll see that what's inside of it is just 1, 2, 3, 4, 5. Very similar to a list, but different on a like sort of fundamental structural level. So that's one way to create an ND array. A lot of the time, though, you don't really want to be creating arrays from lists because you sort of just want to be working with arrays themselves without any of that sort of list in between. So let's ignore this top little bit right here about shape and just focus on this next line of code. So right here, we're initializing an ND array not using a list. So instead, what we're initializing it with is with the shape of the array that we want to create, along with what type of data type we want to store inside of the array. So one important difference between an ND array and a list is that ND arrays can only hold a single type of value. So this myList, it could hold integers, it could hold strings, it could hold doubles, it could hold any number of things. But an ND array can only hold one of those. In this case, dtype is the type of data which we want to store. So in this case, we're saying dtype equals int, so an integer. And then again, we're initializing it using a shape. So this np.zeros function is initializing the ND array. And in this case, it's initializing it with all zeros because it's the zeros function. So the shape is going to be a Python tuple. So a tuple is basically a set of like values enclosed in parentheses. So you'll see in this one, it's 5 comma, and then another parenthesis. So for example, a tuple of 3 and 4 would be a parenthesis 3 comma 4. A tuple of 2, 3, 4, and 5 would be 2 comma 3 comma 4 comma 5. And so what this tuple actually represents is basically the shape of the array. So this is where, if you're familiar with matrices, this might make a bit more sense. But basically, this is basically a 2D storage. Well, so you could have it be a 2D storage. In this case, it's just one-dimensional. It's just of length 5. But if it was to be 3 comma 4, it would be a 2D structure with like basically 3 columns and 4 rows instead of just one long continuous list of values. So the shape kind of determines what shape the ND array like matrix holds basically. And we'll get a bit more into the shape later. So if you're a bit confused, don't worry about it. But so anyway, we're right here, we're using np.zeros to initialize this ND array, and we're using a shape and we're using a data type. If we print the variable we just initialized, we'll see that it's of length 5 and it's filled with zeros. We can then fill that array with different values, and if we print it, we'll see it filled with different values. But again, we'll get to that more a bit later, so don't worry about it too much right now. So basically, what to take away, there's two ways to initialize an ND array. There's either using the array function, in which you give it a list, or there's using the zeros function, in which you give it a shape and a data type. So the shape is important because ND arrays can be many different shapes. So a multidimensional ND array can be initialized. So a multidimensional ND array basically has 2 dimensions. So instead of just being a linear list, it basically have some rows and some columns. There's 2 ways to create a multidimensional ND array. You can either make it from a multidimensional list. So in this case, this is a 2D list, and it's called 2-dimensional because it has lists inside of lists. You'll see that there are 2 sets of square brackets. So my 2D list is a multidimensional list, and then my 2D array is using the array function on the 2D list. And if we print my 2D array, we'll see that it's just a 2D array. So it has columns and rows, basically. You can also just declare a multidimensional ND array without using a list, just using np.zeros. And so that's basically setting shape to be equal to a tuple with the size of the different dimensions. So in this case, the first dimension has two rows, and then the second dimension has 3 columns. So that's why the shape tuple is 2 by 3. And then, yeah, here's just a bit more code filling it up, and you'll see that we can end up with the same thing as we did up there without using a list. So if you want to see what the dimensionality of an ND array is, you can just use the ndim attribute. So you see my ND array. So that was the one we talked about back here, which just used a shape of 5. We'll see that the number of dimensions for that is 1. But the number of dimensions for my 2D ND array is going to be 2. So that's how you create ND arrays which sort of have multiple dimensions. Yeah, how's that sounding to people? Are other people only seeing the first slide? Okay, that's a problem. Let me stop sharing. Hopefully, are people seeing stuff?
Yeah, we can see.
Okay, and you weren't able to see it before, is that correct?
Yeah, so I was following along with the slides for the shape.
Oh, I see. Okay. Yeah, so let me just send those links again in chat in case you do want to follow along, but yeah, sorry. Okay, hopefully it's showing now though. So just sort of to quickly review, there's the import statement that I was talking about. So import NumPy as NP. We have the list, so my list equals, and then the list right here, and then using the np.array function to basically get an array from a list. We have the shape tuple that I was sort of talking about. Definitely let me know if anyone would want some more explanation on how shape works. And then, yeah, sort of the multidimensional stuff. So the 2D list and then the 2D array you can see right here. And then the ndim parameters, using the parameter to see the dimensionality of the list. Would anyone like me to go back to something? Cover it again now that we have the slides working? All right, well, just let me know in chat if, yeah, just let me know in chat. So actually accessing values inside of an ND array is pretty easy. So we created this variable called my2D ND array in the last slide. And basically how we can access, so this is what it actually looks like. If we print it, this is what we see. We see basically this 2D structure with a bunch of values, some in different columns, some in different rows. And we can think of it as having two axes. So every multi-dimensional, well, so every ND array will have a number of axes. Every multi-dimensional ND array will have a number of axes greater than one, because a one-dimensional ND array is just like basically a list. And we can label the different values along each axis. So in this case, axis 0 is going to be the rows, and axis 1 is going to be the different columns. And so if we want to get the first set of values in the 0 axis, we'll see that it's 4, 5, and 6. And if we want to get the the 2 index for axis 1, which is the columns, we'll see that we get 3 and 6. So say we want to reference the value 6 from the array above. So we're going to use square brackets along with the name of the variable, and then we're going to use the values, the indices in the different axes to reference it. So 6 is in the 1 position in the 0 axis, and in the 2 position in axis 1. So inside of the brackets, we're going to have 1, 2. So 1, 2. So yeah, so this is going to be axis 0. This is going to be axis 1. And if there's going to be more than 2 axes, you'll just continue adding commas and numbers. So I've sort of been talking about these multidimensional ND arrays as having rows and columns, but this gets pretty complicated when dealing with arrays of more than 2 dimensions. So for bigger arrays, it's more useful to talk about the axes sort of more generally without really, even though rows and columns are a helpful visualization, they are less useful when it comes to more complicated arrays. So in the future, I'll be talking about axis 0, axis 1, and axis 2 rather than rows and columns. So this is how you can access a particular value. For instance, if you wanted to access the value 2, it would be 0, 1. If you wanted the value 4, it would be 1, 0, and so on. But if you want to access multiple values, you're going to use something called a slice. So slices in Python are used for many things. They can be used with lists, and they can also be used with ND arrays. So let's look back to my list. So my list is going to be initialized with the values 1, 2, 3, 4, 5. And then this syntax right here, where instead of being separated by a comma, they're separated by a colon. This is what determines that it is a slice instead of referencing a specific value. So using my list, the slice from 1 to 3. So the indexes of this list, right? They aren't just 1, 2, 3, 4, 5, because in programming, for some reason, we decided to start by counting from 0. So 1 is in index 0, 2 is in index 1, 3 is in index 2, 4 is in index 3, and so on. So these values right here in the slice are referring to those indices rather than the value inside of it at that position. So my list, the slice from 1 to 3, is going to be the section of elements from the first indice to the third indice, non-inclusive. What that means is that we're going to go from 0, not included, 1, that is included, 2, so that's in between, so that's also included, 3 isn't going to be included because the last value is non-inclusive, it's exclusive. So if we print my list from 1 to 3, we'll get the value 2 and we'll get the value 3. So if we were going to do my list, the slice from, say, 2 to 4, what we would do instead is we'd say 0 wouldn't be included, 1 would not be included, 2 would be included, 3 would be included, and then 4 would not be included. So from 2 to 4 would be the values 3 and 4. This can be any size. So if you wanted, you could say 0 to 5, and that would include every value in the list. Alternatively, you could just use the colon without a number in front of it, and that's going to reference all the numbers from the beginning of the list up up to the third index without including the third index. So that would be 0, 1, 2, and then it would cut off. Alternatively, you can use the colon after the number with no secondary number to reference until the end of the list. So this would be 0 not included, and then 1, 2, 3, 4 all included. So that's why it would print 2, 3, 4, 5. Finally, you can just use a colon. It doesn't change anything though. It just will do all values. So you can use these slices to basically slice an ND array as well. So slicing a one-dimensional ND array is going to be the same as slicing a one-dimensional list. But you can also slice a multi-dimensional array. So say we have this array up here, and we just want to access a single row. So what we're going to do is we're going to use 1. So we're going to access the 1 index of axis 0. And then for which elements we want in axis 1, we're going to say colon. So all of them. We want all 3 of these values. We want the 1 index for the rows, and we want all of the column values. So when we use this syntax right here, it's going to print out the values 4, 5, and 6. You can also do this for rows. So for instance, we want every value along axis 0, but we only want the values that are in index 2 along axis 1. So that's going to be index 2 along axis 1, and then all values along axis 0. So that's going to return 3 and 6. So just sort of to make sure people are following along. So what is this next line going to print? So my 2D ND array, and then colon, comma, colon 2. If you think you know, just type it in chat. Okay. Yeah. So let's, it looks like people are getting the right idea. So it's going to get every element along the 0 axis. So that basically includes everything at this point. And then it's just going to get the values along the axis 1 up to the number 2. So it's going to get 1, 2, 4, 5. And it will keep the 2D array structure. So yeah, I like Rachel and Rita put sort of, they'll still be in sort of separate, separate sections. They aren't going to be a single list. But yeah, so great. So that's how to slice, sort of take apart an ND array. You can also perform other operations with ND arrays. So this is sort of where we get into the matrix-like stuff. So we can sort of ignore this stuff up here for now. Mostly what I want you to pay attention to is the fact that we're using np.zeros to initialize an ND array. It's going to have the data type int, and it's going to have a shape of 4 by 4 by 4 by 4. So this is a 4D array, so it's really hard to visualize. We could print it out, but it would be pretty hard to parse what's actually going on inside of it. Instead, what I'm going to tell you about this array is that basically I've constructed it so that when you choose each index among the 4 axes, it basically adds the indexes together, and that's what element is stored at that position. So the element stored at 0, 1, 2, 3 is 6, which is 0 plus 1 plus 2 plus 3. But don't worry too much about that. Let's just pay attention to this value 6, though. So this array is filled with many different values. One of them just happens to be 6, but say we wanted to add 1 to every single value in this big int array. So one way to do this is to create an array full of 1s and basically add it, overlay it, and add it on top of the array we already have. So we're going to do that by using this ones function. So you'll notice that the 1s and the 0s function actually look very similar. And that's because they basically do the same thing, but instead of initializing an array filled with zeros, it initializes it filled with ones. So the shape of this ones array is going to be the shape of the big int array, and the data type of it is going to be the data type of the big int array. And we're going to call that new variable the ones array. So if we create this one array and we add it to the big int array, we can save it as a new variable, this +1 array. One way to check that every element did indeed have 1 added to it is we can just check this value that we checked before, right, in the big int array, but we're going to check it in the +1 array instead this time. And we'll see that it's a value of 7 instead of 6. And this is going to be true for every single element inside of the array. It just basically has had 1 added on top of it. So here, I'm going to do one array plus one array, and basically we're going to get a 2 array. So we have, our array of 1s, and we're basically adding it to itself. So every single value is now going to be a 2. So one other operation you can do other than adding arrays together is you can multiply them. So here I'm multiplying big int array by the 2 arrays, and I'm going to call that the multiply 2 array. And basically, every single value in the big int array is now multiplied by 2. And if we check the value we checked before, that was originally 6, we'll see that it's now 12. And that's the same for every single element in this array. So even though it's 4-dimensional and it's really hard to visualize, every single element in it was multiplied by 2. So you can add arrays together and multiply them together. If they have the same shape, it's sort of a very straightforward operation. There's one other type of operation which you'll probably end up running across, and that's concatenation and stacking. So Rita just asked, can we multiply by scalar too? So yes, you actually can just multiply by a scalar, and it works about how you'd expect it to. So if you had switched this out and said big int array times 2, it would have done the same thing. But yeah, if this 2 array was filled with lots of different values, each element would be multiplied by different values rather than all multiplied by 2. But yes, you could in fact simplify this to be big int array times 2 and have the same effect. Same up here, you could have done big int array plus 1, and it would have added 1 to every single element individually. It's one of those nice things that NumPy just kind of takes care of for you. But so let's move on to concatenation and stacking. And you'll notice I got a lot less creative with my array names. There've been a lot of them at this point, so I'm just going to start calling them array 1, array 2, and so on. So I'm going to use the array function to initialize these from some lists. So this array 1 ND array is going to have the form of 1, 2, 3, 4. It's going to be a 2 by 2 array. Array 2 is also going to be a 2 by 2 array. It's going to be 5, 6, and then 7, 8. So concatenation is joining arrays along a pre-existing axis. And what you can sort of think of is you can sort of think of just smushing them together. So if you were going to smush these 2 arrays together along axis 0, which is visualized as rows, but is technically just axis 0, if you're going to merge them along axis 0, you'll see that it now becomes the matrix 1, 2, and then 3, 4, and then 5, 6, and then 7, 8. If you had sort of pushed them together along axis 1 instead, you would see that it becomes the array with 1, 2, 5, 6, and then 3, 4, 7, 8, sort of like vertically, right? Or horizontally. But remember, these are sort of visualizations of the concept of just pushing them together along the 1 axis. Sometimes you don't want to concatenate them though. Sometimes you want to stack them. And stacking is basically joining arrays along a new axis. So say you have a bunch of 1-dimensional arrays. Stacking them would basically stack them one on top of the other, and you'd basically end up with a 2D array. So you'd have added a new axis to the arrays, and that's basically what's happening with stacking. I should quickly go over the syntax of these functions. The first parameter you pass to them is a tuple. So not of numbers this time, but of the arrays you want to concatenate or you want to stack in the order that you want to concatenate or stack them. And then the second parameter, the axis, is the axis that you want to basically merge them together at. So with concatenation, if you merge them at axis 0, it merges them at the pre-existing axis 0. If you stack them at axis 0, it creates a new axis 0. And what was axis 0 and what was axis 1 basically shift over and become axis 1 and axis 2. What that visually looks like is that we can see that 1, 2, 3, 4, and 5, 6, 7, 8 are kept as two separate 2D matrices, but now they're stored in basically a 3D matrix, which is why it starts to get weird visually. They're sort of more back to back, you know, here's one and here's the other, but they're more back to back than sort of merged together. So concatenate result. Yeah, there's still stacking it still results in a single array, but it's of a different shape. It's of a different dimensionality than the original two arrays. Basically, in stacking, all the original arrays will still sort of retain their original dimensionality, but then just have one extra axis, which sort of represents all the different arrays being added together. So array 5 is a single array. It's just of dimensionality 3. And basically, so array 5 is a 2 by 2 by 2 3D matrix. And maybe the easiest way to think about it is that, so for array 5, if we were going to pass it the value 0, 0, 1, so if we did that, array 5, passing it 0, 0, 1, the value it'd be referencing is the first array, and then the first value along the first axis, which would, or the first axis, which would be 1 and 3, and then I think I'd need to check that in an interpreter, but I'm pretty sure that would return the value 3. No, it would return the value 2. It would return the value 2. And the reason why is because the 0 would refer to which of would, this is where it gets a bit complicated with thinking about it visually. So stacking them, I think I'm going to struggle to explain this. Stacking them puts them back to back. So we have these 2D arrays back to back. So the first axis chooses which of those basically to go to. The second axis is like the row. So the second axis is 0, so the 0 row. And then the third axis is basically the column. So it's going to be 2. It's going to be this value on the second or on the first array. That was pretty complicated. If we do 1, 0, 1, so instead of 2, we're going to get 6 because we'd be accessing sort of this portion of the array. This is one of those things where you might just need to play with it a bit on your own to sort of get a feel for it. Hopefully it's one of those things where visualizations are nice, but they don't always work out the way you'd expect them to. I would say if this confuses you, just look into it a bit more after this workshop, and hopefully if you play around with a few ND arrays on your own, you'll be able to figure it out. And yeah, see you, Kappa. Thanks for coming by. So at this point, we've talked about a lot of different stuff with ND arrays. We've talked about how to initialize them, how to put values into them, and how to sort of alter them in relation to other matrices. So sort of one final thing to sort of gauge how everyone does with this is I'd like to set a sort of a coding challenge for you guys. So now that you've seen how to sort of work with and manipulate ND arrays, it's good to try and create an array of your own, sort of see if you can figure out how to put the pieces together to do this. So if you remember the array which added the axes, so it added 4 numbers between 0 and 3, so that was over here, the big int array, right? You put in some different values and it basically added them together more or less. It was this 40 array where each element in the array was the sum of the indices. So the challenge I'm going to propose to you guys, sort of with the last 15 minutes we have in the workshop, is to make an ND array which adds 4 numbers, which range from 0 to 9, in one array which multiplies 4 numbers from 0 to 9. So I'm putting adds and multiplies in quotes because really the array just stores the results of all those operations. It doesn't really actually add anything, but it's sort of neat to think of it as adding or multiplying. And if you guys need some clarification on that, just ask and can try and do it. Yeah, if you need, so I would suggest doing this either in the Python interpreter if you have access to it, or using just repl it. So that would be, I'll type it in chat again, but it's just repl.it. And it's sort of this nice way to program Python without a lot of setup. But yeah, if you sort of want somewhere to get started with this, so I believe just further up in chat is the slides and as well as the code that we've sort of been looking at. So looking at that would be a good place to start, but I'll also just direct you to this part. So this was sort of where we set up that original adding matrix, where we created the 4 by 4 by 4 by 4 matrix with integers. And then we used a bunch of for loops to basically set all of the values inside of that array. Yeah, so I think I'll sort of leave everyone to it. But yeah, just feel free to ask if you have any questions. So first thing is just going to be importing NumPy. So I'm just going to do it as NP. But the big thing is sort of figuring out, okay, we want to create a matrix. And if we sort of look back to what we want it to be, we want it to add 4 numbers from 0 to 9. So basically, we want there to be like an array, and we want it to be like, if we type in like 1, 1, 1, 1, we want it to be 4, something like that. What that tells us is that we want our array to have 4 dimensions because each of these indices needs to be an axis in our array. So sort of to do that, to create, this array, I'll just call it R1, we'll want to initialize an array. So to do that, we use the np.zeros function, and we want to give it a shape, which we'll fill out in a second, along with a data type, which we're just going to say is an integer. So for the shape, we want it to have 4 axes. So we're going to have 4 values inside of our tuple. And for each of these values, we basically want it to be the size of the axis. Because we're adding numbers from 0 to 9, we're basically going to want there to be 10 values because 0 to 9 is 10 values. So basically the size of each of these axes we're going to want to be 10. So doing this will sort of give us the array that we can start to work with, array 1. There can be a better name than that. Let's call it like, yeah, like the add array. So now we've created an array in memory with 4 dimensions, each of size 10. We can see this just by looking at the shape parameter of our array, and we'll see that it's 10 by 10 by 10 by 10. So sort of as we saw back with the big int array, the one in the slides, is there were 4 for loops. So a for loop basically iterates through different values. So right, so for I in range 4. And we had 4 of them. So let's just do something similar like that here. Let's basically just copy the code in the slides. So for L in range 4. And then let's just set up the add array. So we're going to reference the particular element at the coordinates I, j, k, and l. And then let's just try setting it equal to I plus j plus k plus l. So if we do that, basically these four for loops will iterate through each of the dimensions, and they'll iterate along it for the first four numbers. And they'll basically set each element at those positions to be equal to the sum of those elements. So now if we look at the add array and we pass in the value, like say 2, 3, 1, 1, we'll see that it's the value 7, which is 2 plus 3 plus 1 plus 1, which is kind of cool. It's kind of neat. But what we're really doing is we're just referencing a particular value inside of this 4D array, which we already created. So one problem with this is that we haven't actually done it from the digits 0 to 9. We've only done it from the digits 0 to 3. So if we were going to do something like even like 4, 0, 0, 0, it would just be 0. We haven't changed it. It's just still at 0. And so we're going to need to change like the for loops to do this. Instead of going from 0 to 3, we want them to go from 0 to 9. So if we instead did for I in range 10, and then for j similarly, so now we can set all the values in the array. So I, j, k, and l, and just set them to be the sum of I, j, k, and l. And now if we do the add array with 4, 0, 0, 0, we get 4, which is what we're looking for. So this is sort of the process by which we can create the add array to add 4 numbers from 0 to 9. So we could do like 4, 5, 6, and 7, and we'll get that the element at that position is 22, which is indeed what we're looking for. And we can do it all the way up to 4 nines, which will give us 36. So we're going to want to do basically the same thing to get like a multiplication array. So we'll want to create a multiplication array using np.zeros. We'll want to give it a shape, and we're going to want to give it a data type. So that'll sort of be the first step. After that, we'll just use the for loops again, but instead of adding numbers together, we'll want to multiply them together. So let's just work it out for the multiplication array. So for the shape, it's going to be the same shape as the one we had above, where it's going to be a 10 by 10 by 10 matrix. And if we just go into the for I loops again, so this time, instead of adding numbers together, so instead of adding the element at I, j, k, and l, we'll just want to multiply them. So if we run this for loop, we'll get the multiplication array. And if we just check that, so say we do it at 1, 1, 1, and 7, we'll see that it's 7. And if we do that at like, I don't know, 9, we get that it's 9. And if we do it like, I don't know, it's hopefully something easy to multiply because I can't do too much complicated multiplication in my head. Yeah, so like 0, 9, 8, 7, since there's a 0 there, it all multiplies out to 0. And then we could do something like 4 nines, and we get it to be a really big number. Yeah, so that's sort of how you go about creating these two separate arrays. Yeah, and just sort of, if you're curious, if you try and reference a number bigger, it'll just give you an error because it's sort of out of bounds of the matrix we just created. yeah, that's sort of generally how you could go about creating two arrays to sort of serve this purpose. And you don't really need an array to add four numbers and multiply four numbers, but it's just a good way to sort of get used to the different syntaxes we're working with, sort of initializing arrays, accessing elements inside of them, and then, yeah. So if, say we wanted to, this actually might be a good chance to use this stack method. So say we had this add array and this multiplication array, and we wanted to create a single array which could do both functions, which could both add numbers and multiply numbers. So what we could do is we could make like a combo array, and we're going to use np.stack to do that. So we want to stack the add array along with the multiplication array. So those are going to be the two arrays we pass in as parameters, and then we can stack them just along axis 0. So this would actually this will be a much better demonstration of what's going on in stacking. So say we have this combo array. So if we look at the number of dimensions it has, or ndim, we'll see that it's 5 dimensions. And so say we wanted to add the four numbers 0, 1, 2, 3. The way we would do that is first we'd specify basically whether we're using the add array or the multiplication array, and then we'd pass in the four numbers we wanted to add. So that would basically add the four numbers. If we change this to a 1, it would instead multiply them. And if we change this back and we did 4 different numbers, so let's just say a bunch of 3s, they'd be added. Similarly, they'd be multiplied. If we did some number bigger than 1 in this, we'd see that it's out of bounds because we only stacked 2 arrays. So there's only going to be a 0 or a 1 as an option along axis 0. But you can sort of see here how they got stacked together like that. If you had, instead of stacking them, concatenated them, so let's do a concat array with the add array and the multiplication array. Right, it's not dtype, it's axis. So if we were going to concatenate them, we'd see that the number of dimensions is still 4, which is pretty weird. This array that we just created by concatenating them is going to be a bit tricky to understand. Basically, if we look at the shape of it, we'll see that it's a 20 by 10 by 10 by 10 matrix. So basically, they got jammed together along the 0 axis. So now if we wanted to add a number, if we wanted to add 0, 1, 2, 3, it would be the same process. So it would be 0, 1, 2, 3, and we'd get 6, and we could change that up, and we could say 3, 2, 1, 0. It'd do the same. We could even add 9s, all the 9s together, and it'd be the same because there's only 4 dimensions. But if we wanted to multiply numbers, it'd be a bit different because basically we'd have to subtract 10 from the first number. So if we wanted to multiply 9, 9, 9, and 9, we'd have to do, or not subtract, we'd have to add 10 to the first number. So if we ran this, we would basically get the same as what we would get in our multiplication array for 9, 9, 9, and 9. And that's basically because they were jammed together along the 0 axis. If we wanted to multiply something, if we just did 10, that'd be 10 plus 0. So we would just get, right, not for the multiplication array, for the concatenation array, we would just get 0 because it would basically be 0 times 9 times 9 times 9. But yeah, hopefully that illustrates a bit better what the difference between concatenation and stacking is. And how they work a bit differently. In this scenario, stacking is a lot more useful, but in other scenarios, concatenation will be much more useful. But yeah, so it's been a lot of information in this workshop. Thank you all for sort of sticking with me. Yeah, I hope you've learned a bit about NumPy, but it is 7:31, so I'm gonna let all of you go. If you have any questions, just let me know. I'm happy to answer any more.